Now let's look at a different kind of plot. This is not a time series plot. This is a plot for a cross-sectional data. So data collected at a particular instance in time. So here we have data for 100 hot growth companies. So we have the rank of the company based on some combination of factors. Then we have the return on capital for that company and the price to earnings ratio, PE ratio. So what we have are numerical data. Then we can plot these as scatter plots. Yeah. Suppose we want to plot PE ratio as the Y value and return on capital as the x-axis. Okay. Based on the return on capital, we want to predict what the price to earnings ratio will be. So then when you have the first column as X column and the second column as a Y column, then we can highlight both of those columns like that, shift end down, and we can generate our scatter plot with both columns highlighted like this. So if you go to insert and select scatter plot, okay. Now for scatter plot, don't connect the points. Okay, if you connect the points, you get a jumbled graph like this. It doesn't make any sense. So you need to select one that does not connect the points. Okay, so it automatically will take the first column, put that in the x-axis, and the second column, and make that into y-axis. Okay, so now let's add some axis titles. Okay. Axis titles. Okay, so that one is PE ratio. Okay, and this one is return on capital. Okay, now this is a scatter plot of P ratio versus return on capital. So let's say versus return on capital. So this is one scatter plot, and you can see that there is a bunch of companies cluttered around here. And as the return on capital increases, there is a general trend of PE ratio going up. So it's not, the relationship is not perfect, but there is a general trend. Now suppose we want to prepare a scatter plot between rank and return on capital, with rank being the x-axis. Once again, since the x-axis is to the left, the y-axis value is to the right, we can highlight the two columns like that. Okay, and then insert a scatter plot, so without connecting the points, and you'll have a scatter plot. And here, so again, let's add the titles. So here this will be rank versus return on capital. Okay, and then let's add the title. So title here on the x-axis is rank, and y-axis is return on capital. Okay. Now the rank goes only up to 100, so we can control the x-axis, okay, by clicking the axis. Okay, more options. So here, make sure that the horizontal axis is selected. And you go to minimum is 0, maximum, okay, here 120, change that to 100. Okay, so we can now examine the scatter plot, and you see initially there is an exponential kind of decline when you go from the first rank down to up to about 20, and beyond the rank of 20 the return on capital is pretty much about the same. There is a slight decline over the ranks, but it is pretty much the same. Now suppose we want to plot rank and PE ratio as a scatter plot with rank on the x-axis and the PE ratio on the y-axis. So now, since these are separated, we can highlight the PE ratio first. Okay, make sure that you highlight all the 100. Okay, there is a missing value in between. So if you use shift down arrow, it will stop with this missing value. So you need to make sure that you highlight all the 100, okay, including the missing value down there. Okay, then you do a scatter plot. Now we need to add the x-axis values. Remember, we only highlighted the y-axis, so go to select data with the graph selected. Okay, the horizontal axis labels is irrelevant in this case because it is a scatter plot. We must have values for the x-axis. So select the PE ratio and edit. Now here is a place where you can enter the x-axis values, and they go from A5. So end down arrow goes all the way to 100. No, not that one. Okay, so x-axis values goes from A5 all the way to the end. Okay, so now we have the scatter plot. So let's give ratio. This is rank versus P ratio, and let's give labels, axis labels. So this will be rank, and that will be PE ratio, and we can change the scale for the x-axis. Okay, more options. So change that to 100. So now we have a scatter plot of PE ratio versus rank, and it looks like PE ratio is sort of about the same, except for around here. Okay, the variability decreases as the rank increases, but the average PE ratio seems pretty much the same irrespective of the rank. Okay. So we looked at 3 different scatter plot examples with these 3 columns, and you can see the relationship between a pair of numerical variables with one plotted as x-axis and one plotted as y-axis.